Hi guys, I hope you guys are doing well. Today I'm going to be going over number 42 from chapter 14, and part A states that the 70 kilogram student balances a 1200 kilogram elephant on a hydraulic lift, and our question is, what is the diameter of the piston the student is standing on? First, we want to equate our equation so that we have the pressures from the left side of the hydraulic lift equal to all the pressures on the right side of the hydraulic lift. So first we have P1 and P2. Since P1 and P2 are at the same level, they will cross each other out because they are equal in quantity. And secondly, we have F1 over the area. So we have this first force over the area in which the student is standing on equal to F2, all the pressures forces from the elephant on the piston over the area that it is standing on. So then here we're left with F1 over A1 equal to F2 over A2. By substituting in these equations here, we get mg over pi r squared. So here we have the mass of the student times gravity over the radius and width from the area and the area that it's standing on. Same thing over here, but with the area that the elephant is standing on and its weight. From this equation here, we're going to do some algebra to rearrange and get R1 by itself, and we get that R1 is the square root of M1 times R2 squared over M2. By substituting in our values, we'd get that R1 is 0.24 meters. And since our question is asking for the diameter of the area in which the student stands on, we simply multiply this by 2, and we get that the diameter is 0.48 meters. For part B, it states, when a second student joins the first, the piston sinks 35 centimeters. And the question is, what is the second student's mass? So here, our equation is very similar to the one from before, but on the right side here, since the students and the elephant are no longer at the same height, we have this additional force or pressure put on P2 from the oil that is above this point. So we have the density of oil times gravity times the height. So first we have to figure out what our height is, and we do this using area in volume. So we know that area 1 would be pi times 0.24 squared because we found this radius in part A, and if we multiply that by the given information in this problem, which is a 0.35 meters, we get that the volume displaced of oil is 0.06 meters cubed. Now if we take this information, since we know that the volume displaced on this side is equal to the volume displaced on this second side, we know that 0.06 meters squared will be equal to the area 2 times the height, and rearranging this equation, we get that h equals the volume over area, so we know that the height is 0.02 meters. So now we know here that the force is the mass times gravity, but the mass here is now the mass of student A plus the mass of student B. And we know what MA is, but we don't know what MB is, and that's what we're trying to solve. So when we substitute our values, we get in this first term that MA plus MB times gravity over the area is equal to the force of the elephant over area plus the pressure of the oil. Rearranging all of this, we get that MB is equal to 69.2 kilograms plus 13.57 kilograms subtracted by the 70 kilograms, which is 12.69 kilograms, and that would be the mass of the second student.